Okay, hello. I think I finally sorted out all my technical issues. So welcome to my Twitch stream. I hope this is working fine. I hope this will give us a nice video to watch later on, which I'll upload to YouTube. So if you're watching this on YouTube, please click that like button and subscribe. And if you want to suggest future topics for me to do, please let me know via the Twitch chat or via the YouTube comments, which you can put below the video. Now this is envisaged to be a revision topics type activity. So revising for GCSE maths, for those of you wanting to do GCSE maths in the summer, the idea is that you will watch these sessions. They're probably going to last about 20 to 30 minutes each time, and they'll give you some good bite-sized chunks of information for stuff that you'll probably have to learn for the summer. All of the things I'll do will be concentrating mostly upon past exam questions. There are plenty of videos out there to teach you the content from scratch, but I'm anticipating that many of you would have done those videos or done some sort of teaching in the past. So what I'm doing is just revising the key concepts, going through a couple of tricks and just making sure you're ready for the exams in the summer. So this is just an idea for a revision only. If you want to see any of the other content that's out there in terms of stuff that's teaching you from scratch, there's plenty of websites to choose and plenty of YouTube videos to choose from. So in front of you, you can see a percentage increases and decreases question. This is based on plenty of exam questions that you'll see online. I'm going to start by showing you a PowerPoint presentation which I tend to show to sort of give you an illustration of the kind of things that you want to be thinking about when you're doing percentage increases and decrease questions. Now for increase questions, you can use a method called scale factors. Decrease questions also use a method called scale factors. Scale factors is a really easy way of doing percentage increases and decreases. You do have to have a good knowledge about what's going on. So for scale factors that are greater than 1, that will always represent an increase. And for decreases, you're using scale factors that are less than 1. Now I'll illustrate what I mean by showing you a couple of examples. These are very typical sort of questions that you might get. Very simple things to look at. This first question here is talking about increasing an amount of money by 20%. So you can see here the amount of money we're talking about is £300, and you're increasing it by 20%. Now what you're going to do is think about £300 as representing 100% of what you start with, so that represents 100%. If you're adding 20% on top, like a little block on top, you're going to have 120% total of whatever you started with. And 120% of the decimal is 1.2. You can see me working that out to the left-hand side. So all you do is you take a calculator, you do £300 times 1.2, and you get 360. Now, as I'm saying, calculator, you'll understand that a lot of these questions are suited to calculator papers. You can do these on paper also, if you're that way inclined. To be honest, a lot of these things do crop up in calculator papers, but if they do crop up in our calculator, you can do it too, very simple, and usually they'll pick easier examples for you to pick from. Let's look at a decrease question, because that's with scale factors that are less than 1. With decrease questions, it's the same sort of thinking you've got to go through. So if you view the £300 in this case as 100% of what you start with, and you take a 20% chunk away, so you're taking 20% off your total, you're going to be left with 80% of what you started with. So what you're really doing here is working 80% out of what you started. Because you started with £300, you're doing £300 times 0.8, so that's 80%, 80 divided by 100, and you do £300 times 0.8, you get £240. This method is particularly useful when you're doing questions that are called reverse percentage questions. So you'll see these come up quite commonly, and you'll see a lot of examples of these out there in textbooks and so on. This one's talking about a house. It's been increased in price by 20%, and you can see the new price of the house is £240,000. It's asking you the price before the increase. In other words, before you did that particular 20% increase. Again, if you're thinking about that as a percentage, that's 120% of what you started with. So 1.2 is a scale factor in this case. What you've got to do is, because you're doing the opposite of that scale factor increase, you'll take the amount of money you end with, the 240,000, and you divide by 1.2. So 240,000 divided by 1.2, you get 200,000. Let's look at a couple of exam questions now and sort of show you that in action. So you can see here, this particular question is talking about Jack investing £2,000 at 5% per annum, and importantly, he's talking about compound interest. Now, compound interest is a concept that you would have learned in maths before. It means that you're adding an amount of interest per year based on whatever you've got in the bank account, the balance in the bank account. So you start with a balance, you add 5%, next year you add 5% again, the next year you add 5% again. It's always worked out on what the balance is at that particular point. That's the crucial difference. Now this particular question is asking me to work out the value of Jack's investment on the 1st of July 2006, having invested his money in 2004. Because he's investing £2,000 and 5% is the compound interest rate, we need to think about 100% plus that 5%. So it's 105%. 105 as a decimal is going to be 105 divided by 100. That's going to be 1.05. So 1.05 in this case is going to be my scale factor. Now because I've invested £2,000 at 5%, but this time in this case for 2 years, because we're starting in 2004 and we're ending in 2006, you've got to do that increase not once but twice, 1.05 to the power 2. So you're going to have £2,000 times 1.05 squared. So £2,000 times 1.05 squared. What you do is you take your calculator. These modern calculators are really quite interesting and handy to do this. You can do this really easily. And just show on the calculator there, £2,000 times 1.05 squared. So if you press that button, the equals button, you get 2,205. So that's £2,205. Now, each and every time you're doing a question like this, you've just got to make sure that you end up with more than what you started with, because after all, it's a percentage increase. Now, question 2 down the bottom here is talking about a sale and normal prices being reduced by 20%. I'm hoping you can spot this as being a reverse percentage question. So this is a reverse percentage question, just like the one I showed earlier. So just in case you forgot, here's the one I introduced earlier, talking about a house price been increased. What was the price before the increase? So we were dividing by a scale factor in this question. Here we've got a sale and the normal prices are reduced by 20%. So reduced by 20%. The washing machine has a sale price of $464. Now I can represent this using a diagram. So here's my diagram. And the sale of the washing machine before the sale represents 100%. Whatever reduction you're doing, you're going to be reducing that down to 80% of what you started with, because we've got the 20% that we've lost. That 20% that we lost has been taken off the top, leaving me with 80% left. So to get from this to this, I'm having to work out the scale factor, and the scale factor here would have been 0.8. So 100%, whatever it was, the amount of money, you'd be multiplying by 0.8 to get this price. We're told in the question that the sale price is $464. So that's the sale price. We want to get back to what it was originally. So if we multiply by 0.8 to get to this, to get back to the original, I have to do the opposite. So dividing by 0.8. So we're going to divide by 0.8 to work out what I had to start with. If you do 464 divided by 0.8, and again we're going to do that on our calculators because this wasn't a calculator paper or a question like it was on the calculator paper, you're going to get £580. So £580 is the price before the sale. Now this question is quite interesting because it talks about not what the price was before the decrease. It's actually asking how much money is the normal price of the washing machine reduced. In other words, how much difference is there between this price and this price? So we have to work out a difference between this price, the price before the sale, and the price in the sale. For 580, take away 464. So again, you can work that out real quick using a calculator, or just show some calculation. You'll get £116 really quickly. That gets you 3 marks, no problem. Moving on, I'd like to show you a second question, again very similar to the previous one, and again it's a reverse percentage question, but it's a very similar question. So this is talking about a price and a sale of a TV being reduced by 25%. A week later, the sale price of the TV is reduced by 15%. The price of the TV is now £293.25. What was the price of the TV, crucially, before the sale? So again, reverse percentage because it's before the sale. Again, we can illustrate this with a diagram. Whatever price I started with, I'm going to be reducing it by 25%. So 25% taken off leaves me with 75% left. So to get from the original price to this price, I'd be doing 0.75, multiplying by 0.75. I hope you can see that. Just lift it up for you to show you that. Make my decimal point a bit bigger. And then again, because you're reducing it again, but this time by 15%, we're taking 15% off my price. If I take 15% away from 100%, I'm left with 85%. So my second scale factor here will be 0.85. So there's two scale factors here in play. We've got the first scale factor as 0.75, the second scale factor is 0.85. We're told in the question that the final price is 293.25. So 293.25. Just show you that real quick. Really tiny writing, sorry. I need to go backwards, so I need to reduce by, I need to increase the price now, but backwards, but of course I'm doing the opposite of multiplying by 0.85 and the opposite of multiplying by 0.75. So all I do is I do 293.25 and I divide it by 0.85 and I divide it again by 0.75. Now what's good again about modern calculators is that you can show that all in one stage. So if you key that in your calculator, it will look something like this. So you can see just to the left hand side here, I just show you, I've got 293.25 divided by 0.85 divided by 0.75, and again I'm just going to show that real quick what it gets you, 460. So my price of the TV before the sale is 460. We do just double check to see if that's more than what we started with, and it is, so it does make sense that that should be more. So those are reverse percentage questions, again really easy to do using scale factors. This question here was relatively recent as well. You can see this, I'll just show you. It says Northern Bank has two types of accounts. Both accounts pay, again, compound interest, very common. It's asking for cash savings accounts here, interest at 2.5% per year, so per annum means per year. And this one is a shares account, interest 3.5%, and again per year, so 3.5% per year. It's these two guys, Ali and Ben, which is referred to them as A and B. A is investing £2,000 in the cash savings account, so this one, and B is investing £1,600 in this one, the shares account. Now the key thing about this question, it says work out who will get not the most money, but the most interest by the end of 3 years. So that's the crucial piece of information that we're being asked for. Who's earning the most interest and who's doing it after 3 years. So that's quite important. So I've underlined that because I want to make sure I get this particular question right. I hope you can see this. I'll show you real quick. I'll try and write big for you. So this is A. We're going to show A now. So he was investing £2,000 and he was investing in a bank account that was paying 2.5%. Now again, our scale multiplier here, our scale factor multiplier, would be 100% with the 2.5 added on, so 102.5%. 102.5%. That is the same in decimal form as 1.025. Okay, so dividing by 100, my scale factor would be 1.025. We're doing it for 3 years, so you've got to think about 1.05 to the power 3. So whatever amount of money he has in the bank account after 3 years will be £2,000 times 1.025. Again, this is in the calculator paper, and we can show that on our calculator. £2,000 times 1.025 to the power 3. In case you're not sure where the power button is, it's that one down there with a little X on it. Just make that a little bit better for you. There you go. That little X, the power button, is what you're using. I'm going to press the equals sign so you can see what happens. Press SD, because we want it in decimal form. 2153, again, it's the amount of money, so we're going to go to nearest pence. So 2153.78. We'll stop there, because obviously it's the amount of money. So 2153.78. That's what he has in the bank account after 3 years. Is it more than what he started with? Yes. So that makes sense. Underneath, I'm going to do B. So again, he's investing, again, just refresh the question, £1,600 in this shares account, which is paying 3.5%. So £1,600. We have to think about our scale factor again, similar to this one. So here we've got 103.5%. 103.5% is 1.035. So 1.035. So my scale factor here will be 1.035. Again, doing it for 3 years. So 1.035 cubed. And again, we can use the calculator to work that out real quick. And we can key that in. So I'm just putting that in now. Here we go. So 1.035 squared, cubed, and it's £1,773 and 95 pence. So £1,773 and 95 pence. Now we're going to go to the second thing I underlined here. We've done the 3 years. We haven't done this yet. We haven't looked at the most interest. This is the money they have in the account. This is the money that Ali has, A has, and this is the money that Ben has, B. We want to see how much interest they've earned. The interest that Ali will earn will be 215,378. Take away the 2,000. So that's really easy to do in your head. 153.78 is the interest here. I'm just going to show the examiner what we're doing by making that really clear that I'm talking about interest. So 153.78, and the interest for Ben will be, so a very similar sort of idea. You're going to do that, take away the 1,600, so that's going to be £173 and 95 pence. So the two amounts of interest earned for Ben, for B, 173.95, for A, Ali, 153.78. Who's earned the most interest? Well, Ben has earned the most. Okay, so he's earned the most interest. So although his money is less, he's earned less money, he's got less money, he's earned the most interest. So Ben has the most interest. That's how you get the marks here. It's important to understand that that was how you earned the marks in this particular question. The last part of the question talks about changing the interest rate to 4% and if it has any effect after the end of 3 years. Of course, Ben gets the most here. By changing the interest rate in the shares account, he's just going to get more interest. So it doesn't affect it in any way. Ben's still going to get the most. Very straightforward question. But they've thrown that in there just to make you question whether the answer for this particular question is right. So it's quite a tricksy little thing. They're trying to make you go back to this and say, oh, well, have I got the answer wrong? But no, you haven't got the answer wrong. Ben has the most interest here. Ben has the most interest here. It really makes no difference if they're increasing the interest amounts. 2 more questions to show you. Here's one long question I want to show you. I'm just going to flick it up to the camera so you can see it a bit better. Just bear with me a second, I'll just fold it up for you. So here's the first question I would like to look at. So this is saying in 2016 the population of the UK was 6.5 times 10 to the 7, so standard form being used in the question. It says Laura wants to calculate an estimate for the population of the UK in 2020. It's quite important information. 2020, we're told about 2016. This is 2020, so 4 years later. She assumes that the population increases by 0.6% each year. So 0.6% each year. Using Laura's assumption, calculate an estimate for the population of the UK in 2020. So what's happening here is we're increasing our population by 0.6%. So what's our scale factor? If we started with 100% and we've increased it by 0.6%, our new scale factor would be 100.6%. So 100.6%. That is 1.006. It's a very small number, 1.006. We start with 6.5 times 10 to the 7. Okay, we're increasing that by 1.006. So that's the calculation I'm going to do. So that's my original population. There's my scale factor. But I'm doing it for 4 years because 2020 and 2016, 4 years has gone by. So I'm going to have to do power 4 because my scale factor is to the power 4 here because I'm doing it over 4 years. So if I want to estimate the population, I'm just going to throw that into the calculator. Again, you want to be really good at using a calculator to do standard form. Just in case you're not aware, the standard form button is down here, so times 10 to the power x. So I'm just going to do that in the calculator. So that is 6.5 times 10 to the 7, that's what that looks like. I'm going to multiply that by 1.006 to the power 4. So again, I'm just going to show you that real quick. That's how it looks. And I'm going to press equals. And we get this very long number, so 665,74096. Of course, it's population, so we're going to do it to the nearest person. So 66,574,096. Anything like that would be fine. To be honest, I think because they've said estimate in the question, it probably wants a bit more of a vague answer. But I'm just going to write down the whole thing. I can't be wrong if I write the whole thing. So 66,574,096. I think that'll be fine for the marks. The second part of the question, just need to unfold it again. Down here talks about this guy Kieran, who's also assuming that the population of the UK increases by 0.6 each year, and he says that it would take over 80 years for the population to increase by 50% because 50 divided by 0.6 is 83.8, so he's getting 83.3 over 80 years because he's doing 50 divided by 0.6. It says Kieran's method is wrong. Explain what is wrong with this method. Okay, well earlier I talked a little bit about compound interest, and this is a very similar sort of concept. It's compound population growth. Your 0.6% is going to be on wherever the population is at the end of that year. So end of the first year, you're going to increase it by 0.6%. End of the second year, whatever the population is at that time, you increase it by 0.6%. At the end of the third year, population at that time, increase it by 0.6%. This method that Kieran's using is using a method called simple interest, so simple percentage increase. So he's just assuming that it's 0.6 of the original population, and that 0.6 is the same increase all the time. But it won't be, because that 0.6 is going to increase every single year. The 0.6% is going to be worth more every single year, because the population is more every single year. So explain what is wrong with this method. This method is incorrect, because this is assuming that 0.6% is of the original population and stays that way, but we know that 0.6% will increase year on year in a compound way. So any sort of explanation that gets you that will get you the single mark here. Finally, the last part says, assuming that the population of the UK increases by 0.6% each year, show that the population of the UK each year forms a geometric progression. Geometric progressions have a starting number, so here in this case it will be A, my starting number. 6.5 times 10 to the 7 is my starting number. My common ratio is whatever I'm multiplying by each year, a factor that I'm multiplying by each year. We've already discussed that, it's 1.006. So all you have to do here is explain that you're going to be using for this question a starting number multiplying by 1.06006 for each year that you hold the population and you're studying it. So after the end of the first year, 6.5 times 10 to the 7 times 1.006. After the second year, 6.5 times 10 to the 7 times 1.006 squared. After the third year, 6.5 times 10 to the 7 times 1.006 cubed, and so on. As long as you write an explanation that's talking about these two figures and talking about a compound increase, you're absolutely fine. You'll get enough information in there to get the question. You just have to show what numbers you're using. But scale factors, because we've used that particular method, is very suited to this particular part of the question. It really just explains it for you because of what you've done earlier on. This last question, I wanted to draw attention to one of the key things about exam questions and what you'll see in exam questions, and that's this word, percentage. Whenever you see the word percentage in any question, at some point in the answer, you're going to be multiplying by 100. The opposite type of question will be if you see the percent sign. If you see the percent sign, at some point in the answer, you're going to be dividing by 100. Let's just see that illustrated in some of the questions that I've done with you today. So here earlier, this particular question, I know it was reverse percentage, we divided by we divided 75% by 100, so we divided it by 100. We divided 85% by 100 because we saw the percent sign, we're dividing by 100. Here earlier, again, we divided the scale factor by 100, so here I am dividing it by 100, very well illustrated there. Here again, the washing machine reduced by 20%, but I'm reducing by 20%, which means I've effectively found out 80% of my original price. I've divided that 80% by 100 to get 0.8. And again, in the question we just did, we worked out a scale factor of 100.6 divided by 100 to get 1.06. So whenever you see the percent sign in a question, I'm going to point that to you, every time you see the percent sign, you're going to be dividing something by 100. But this word percentage means that at some point in the question, in answering the question, we're going to be multiplying by 100. Now there are two different ways of doing this question. I'll just read it to you real quick, just in case you haven't had a chance to read it. It's talking about this girl, Jo, who's paid £245 for her car insurance. And this year she's had to pay £883, she's obviously had an accident or something, a lot of an increase there. So it's asking her what the percentage increase in the cost of her car insurance is. Now most commonly, people who are used to doing scale factors will probably do first 883 divided by 245. Now that's not necessarily very wrong. What you'll get when you do that, again this is on the calculator paper, so you've probably seen this question. You do 883 divided by 245 and you'll get this horrible number here. So I'll just show you that. 3.604086163 blah blah blah. That's just a decimal, but we want it as a percentage. Because we want it as a percentage, we're going to be multiplying by 100 because we want it as a percentage. If you take this number and multiply it by 100, we're going to get 360% approximately. Okay, so 360%. Now that's not very satisfactory as an answer, plus it's not quite the answer yet, because we have to think about what that 360 represents. Up here I've left a space so I can show you this illustrated in the diagram. Okay, we had the amount we started with, the insurance in the first year, and an increase. Okay, this is the insurance after her increase. We've worked out that our scale factor for increase here was 360%, or 3.60. It's a lot higher. It's 3.60%. Just show you that real quick. So 3.60. But we know also that this was 100% to start with, and this is 100% in there, and then whatever increase on top. So we have to take account of the fact that the original population is absorbed in my amount that I end with. So I've got to think that this is my scale factor, but of course that includes the 100% that I started with. So back down here when I'm talking about 360, the amount that's left after I've done the increase, you have to take 100% away to account for the fact that I've got 100% of the population incorporated in my figure. So that will then be, if you take away 100%, that's the figure that we already had, you'll get the increase, the only pure increase that's left, which is 260%. I've put an approximately sign because we did approximate it earlier, 260%. The other way of doing this question is to think about how you've increased the price. So 883 take away 245. Okay, we can work that out real quick. Again, calculators make this really useful, but you can do this longhand as well. And we'll get 638. That's the amount of money we've increased it by. If you're increasing by 638, you have to work that out of the original price. What proportion of the original price is this 638? The original price is 245, and because we're doing a percentage, we're going to be multiplying that difference by 100. If you do that on your calculator real quick, you will still get the 260%. And there it is. Again, you're going to approximate it 260% because we only have to be vague here. 3 significant figures unless stated otherwise in the exam. So 260% is quite okay. As long as you do it to 3 significant figures, you're going to be fine. Okay, that draws us to an end of the percentage increases and decreases. I hope you had a lot of information there, and I hope you've learned a lot. If you want to see other things, please, as I say, just request them via the Twitch chat or on the YouTube channel. The YouTube channel will be uploaded later on the day, and I'll put a link on the Twitch so you can go between the two. I hope that was interesting for you. Thank you very much for watching, and goodbye.